Hello friends, this video is brought to you by www.moeteaching.com.
Let us recall the factorization of cubic polynomial. We know that a cubic polynomial has at most 3 zeros. We start with a cubic polynomial. We try to find one of the zeros of this polynomial by hit and trial method. Most of the time, one of the factors of the constant term or constant term multiplied by the coefficient of x cube gives us the first zero. Here the constant term is 3, so the various factors of 3 are 1 and 3. Let us try to substitute x equal to 1 and see if it is the zero of this polynomial, and we can see that yes, x equal to 1 is the zero of the polynomial, as f of 1 comes out to be 0. So we have that x minus 1 is a factor of f of x. Now to find the other factors, we divide x cube minus 3x square minus x plus 3 by x minus 1, and we have learned this process in class 9th. You can go through the videos, or we will quickly revise here. We want to get x cube, so let us multiply by x square. We get x into x square as x cube, and minus 1 into x square is minus x square. Now we need to subtract. X cube cancels and we are left with minus 2x square minus x plus 3. Now to get minus 2x square, in the quotient we take minus 2x. On multiplying we get minus 2x square. Minus 1 into minus 2x will give us plus 2x. Again subtracting will change the signs. 2x square cancels and we are left with minus 3x plus 3. Now to get minus 3x, we multiply with minus 3. Minus 3 into x gives minus 3x, and minus 1 into minus 3 gives plus 3. Change the signs and we are left with remainder 0. So that means the other factor is x square minus 2x minus 3, and we can write the cubic polynomial as a linear polynomial multiplied by a quadratic polynomial. We can factorize this further. We know by the middle term split method. After doing that, we get x minus 1, x plus 1 and x minus 3 as the 3 factors of the cubic polynomial. Now to find the zeros of fx, either this equal to 0 or this equal to 0 or this equal to 0, gives us x equal to 1 or x equal to minus 1 or x equal to 3, implying that 1, minus 1 and 3 are the zeros of fx. Note that we stopped this division process when either the remainder is 0 or its degree is less than the degree of divisor. Let us take the division algorithm for polynomials. The algorithm states that if px and gx are any two polynomials with gx not equal to 0, then we can find polynomials qx and rx such that px equal to gx into qx plus rx. In simple words, we are saying that if our divisor and dividend are two polynomials, then we can find the polynomials qx and rx, which are the quotient and the remainder, such that dividend is equal to divisor into quotient plus remainder. Note here, the quotient and remainder will also be the polynomials. And here rx would either be equal to 0 or degree of rx, that is remainder polynomial, should be less than degree of divisor, that is gx. Let us read the question. Divide 2x square plus 3x plus 1 by x plus 2. Let us start the process. We want to get 2x square, so we have to multiply x with 2x. So let us take in the quotient 2x. Now when we multiply quotient with divisor, we get 2x square plus 4x. Change the signs, we get minus x plus 1. Now we need minus x, so we will multiply the divisor with minus 1 and take in the quotient minus 1. We get minus 1 into x as minus x and minus 1 into plus 2 as minus 2. Now change the signs and x gets cancelled. We are left with 3 as remainder. So here we have px 2x square plus 3x plus 1, gx, that is the divisor, equal to x plus 2, quotient polynomial is 2x minus 1 and remainder is 3. Then by the division algorithm, we will have px equal to gx into qx plus rx. So we get the following expression after division. Let us read the question. Divide 3x cubed plus x square plus 2x plus 5 by 1 plus 2x plus x square. We first arrange the terms of the dividend and the divisor in the decreasing order of their degrees. The dividend is already in the decreasing order of their degree, but the divisor is not. So let us rewrite the divisor as x square plus 2x plus 1. Now the dividend and the divisor are both in their standard form. Now we start with the division. To obtain the first term of the quotient, we divide the highest degree term of the dividend, that is 3x cube, by the highest degree term of the divisor, that is x square, which gives us 3x. That means if we multiply our divisor with 3x, we can get 3x cube. So in the quotient we take 3x, and now we get 3x cube plus 3x into 2x will give us 6x square plus 3x into 1 will give us 3x. We will subtract, so signs will change and the cubic term gets cancelled. We are left with minus 5x square minus x plus 5. Now again, to obtain the second term of the quotient, divide the highest degree term of the dividend by the highest degree term of the divisor. We get minus 5x square divided by x square is minus 5. That means we will take in the quotient minus 5, which on multiplying with the divisor will give us minus 5x square plus 2x into minus 5 will be minus 10x plus 1 into minus 5 is minus 5. Change the signs and we get 9x plus 10. Now the degree of remainder is less than the degree of divisor, so we stop here and get quotient as 3x minus 5, while the remainder is 9x plus 10. So we can write dividend equal to divisor into quotient plus remainder, that is px equal to gx into qx plus rx, where px is given to us and gx is also given to us, and we have already found out quotient and the remainder polynomial, and we get the following expression. Let us read the question. Divide 3x square minus x cube minus 3x plus 5 by x minus 1 minus x square. We first arrange the terms of dividend and the divisor in the decreasing order of their degrees. After arranging, now we have the dividend and divisor in standard form, and let us proceed with the division. We have already discussed division process. So the first term in the quotient would be minus x cube divided by minus x square will give us x, which on multiplying with the divisor will give us minus x cube plus x square minus x. Change the signs and we are left with 2x square minus 2x plus 5. The next term in the quotient would be minus 2, and again we get 2x square minus 2x plus 2 change the signs, and we are left with 3 as the remainder, because degree of constant term is 0, which is less than degree of divisor. So we stop here. Now we have to verify the division algorithm. So let us take the right hand side of the equation and verify that after calculation it comes out to be equal to px. We substitute the values of qx, rx and gx and get the following expression. Now let us open the brackets and solve further. After opening the bracket, we get the following expression. Let us solve this further. We get minus of x cube plus 3x square minus 3x plus 5, which is same as the dividend or px, hence verified. Let us read the question. Find all the zeros of the given polynomial if you know that two zeros are root 2 and minus root 2. Now since root 2 and minus root 2 are the zeros, that means x minus root 2 and x plus root 2 are the factors of given polynomial, and these can further be written as x square minus root 2 whole square, which is equal to x square minus 2. So that means x square minus 2 is a factor of given polynomial. Since fx is biquadratic, so it can have maximum of 4 zeros. We already have 2 of them. To find rest of them, let us first divide the given polynomial by x square minus 2. We know how to find the first term of the quotient. We will divide 2x power 4 by x square. This will give us 2x square. And now on multiplying we get 2x power 4 minus 4x square. Change the signs and get minus 3x cube plus x square plus 6x minus 2. Again get the second term of the quotient, minus 3x cube divided by x square will give us minus 3x. So the next term is minus 3x. Again multiply with the divisor and change the signs. We are left with x square minus 2. Next term in the quotient would be x square by x square gives us 1. So plus 1, and we get x square minus 2. Change the signs and remainder is 0. Now by division algorithm, dividend equal to divisor into quotient plus remainder, which is 0. So we can write the following expression and further solve the quadratic equation by splitting the middle term and solving. We get the following expression. Now these three are the factors of given polynomial, and to find the zeros we have to equate them to 0. We already know that x square minus 2 will give us root 2 and minus root 2. So we can take 2x minus 1 equal to 0 or x minus 1 equal to 0 gives us x equal to half or x equal to 1. So this implies that root 2 that was given minus root 2 that was also given, half and 1 are the zeros of the given polynomial.